Here we have some area, cross-section, volume, and disk method type of stuff. There's all my work, all my answers there. And then when you get to this point here, you could technically just leave your answer like this. They just say like a numeric equivalent there. So if you're wondering about how to do that without the calculator, we don't have the calculator on this one. It's okay to just leave your answer like that. I don't know if they ever did it that weird before there, but you don't have to take it that far. So there you go. All right, so letter A. So we got a couple graphs here. Make sure you identify where your F and your G are at, where your R and your S are. So they're just talking about region R. And then we just want to calculate the area, right? But do not evaluate an integral expression that gives the area of R. So it's just going to be your area is just going to be top curve minus bottom curve. So that's just going to be F minus G from left to right. It tells you between 0 and 2. And so you could just have this written down. So you got top curve minus the bottom curve, left to right. Use the x's that take you across that bounded area in that region. You can just stop right there. If you wanted to, you can also write the equations down, simplify that a little bit, and get something equivalent. But you're welcome to do that. Just make sure you put the numbers on there, just top minus bottom for the area. And then this is a doable cross section. So if they're talking about region S now, and between 2 and 5, and it says region S is the base of a solid, and then it says cross section perpendicular to the x-axis. So perpendicular to the x-axis, that means it's going to be a dx problem, and I draw that line segment perpendicular to that x-axis, and then we always find the length of that s. So that s, when it's up and down like that, we're going to go top y minus the bottom y, which is your g of x. That's the top curve is the g of x, and then the bottom is just your x-axis, which is 0. So your g of x, they told us was that equation. And so that represents the base of whatever your cross-section shape is. So if that's squares, that's one side of your square. But they tell us that that's rectangles. And whenever you do cross-sections, you integrate the area of your cross-section shape. So the area of a rectangle is base times height. So I need to integrate base times height. So I need to integrate this base times it by whatever the height is. They have to give us information about the height if they make us do rectangles here. So that tells us the height is equal to half of its base. So this is the base of the rectangle, which means the height is 1/2 of that base. And so when you do your integral, you integrate the area of that rectangle, which is base times the height. So I'm taking this, timesing it by this. So I just pulled the 1/2 out, and I have that times that. So you identified that guy, you're doing your integral properly. There's nothing crazy, but it tells us between 2 and 5 there. So you're going to have your numbers attached to the integral. Set all of that up with the numbers attached to it because you can get credit for that. So set that up properly. And then this is pretty doable. You just got to multiply that all out. Be careful with that. Multiply it all out to get to this and then integrate it and then plug in top minus bottom. And when I got to that, I was like, I went to like a separate sheet of paper and I was factoring out like a 5 from some of them and a 2 from some of them, and I had to play around with a little bit to even get to that number there. But I did check the rubric. They said as any numeric equivalent to this, I could even kind of show you. I printed out for this guy, like they plugged in, they got like this stuff here, and then they got to this stuff here. But then the rubric says you can get a numeric answer equivalent to that weird looking answer right there. So if you have normal stuff to plug in and it seems normal and it seems easy to simplify, go ahead and do so. But it, and if you do like a little arithmetic mistake there, like it's typically worth a point for that answer right there. So I believe this is worth 4 points. You get a point for the inside of your integral, you get a point for the numbers attached, and then you get a point if you actually like integrate it properly. And then it's just a point for plugging in the numbers there and then just kind of leaving it alone there. So if it looks simple, you might want to do it, go ahead and do it and simplify and get nice fractions like we've done on a lot of the other tests there. If it looks crazy, just leave it alone because they got to accept just a numeric equivalent for that without the calculator right there. So there's that. All right, now letter C. We're going to do the volume of the solid and then make sure you identify which one you are. We're on region S, and then we're just going to use the disk method here. So if you're on the A/B test, you're just going to be area stuff. It's going to be volume with the disk method and then sometimes the cross section. So let's review our disk method here. We know this. We're going about the line y equals 20. That's just our four big scenarios here. So I drew my rectangle perpendicular to that. That was a dx problem. And then the capital R is a distance from the axis of revolution to the farther edge of your bound area. So you're going from there to your x-axis. That straight as a straight edge, that's just 20 units every single time. So the capital R is 20, and a little r is the distance from your axis of revolution to your closer edge. And so that's from an axis down and it's different each time. So anytime you measure from an axis down, it's different each time. It's going to be that number minus y, but it's a dx problem. So you got to subtract out that g of x curve, which is this guy right here. So then once you get your capital R, and you're going just using it as a dx problem. So just left to right, use the x's that take you across your shape. So you got your pi guy out in front. You're going to do capital R squared minus a little r squared. And then you use the x's that take you across your shape there. Remember your numbers and your pi's and be careful. Make sure you remember your squares. So what I did, I'm used to just, hey, 20 minus that. So I put that in parentheses and I distributed the negative through and I made it that. You could have left it just like this and put that inside there. Or if you distribute, make sure when you distribute that you actually like get that sign correct. So this would have been full credit. You could have left it like this. That would have been full credit. You could have also written it like this. That would have also been full credit. And I'm just going to make a note for myself like this is okay here. Just so I know if you're asking questions there. But that's just your capital R squared minus your little r squared. And then let me know if you have any questions there. But that's a pretty good volume stuff there. And keep studying your areas and your disk method. And let's make sure we keep studying those cross sections because there's not that bad. And we can make sure we're getting those and that turn that into a strength of ours. Varnish.